Alrighty, so I don't have lots of videos or audios or slides and that kind of stuff, so I'm really going to be talking about a lot of the experiences that we have when it comes to building our games. And so just to get started, I'm just going to give you a little brief background of where I've come from, what I've done in the industry and that sort of thing, just so you can sort of go, okay, well, I can see where he's coming from. So I founded DC back about 15 years ago now. We did a lot of work for hire stuff for Unreal Engine specific games for a really, really long time. And throughout that time, we worked on a lot of different scales with a lot of different projects, from indie scale to AAA scale. So recently, we just wrapped up one of our bigger contracts with a really big AAA project. And here are a lot of the lessons that I've learned while working on that project. So if you're building an Unreal Engine game today, these are things that I highly recommend that you do. So there is an asset management toolset in Unreal Engine, and you probably should be using this. So the asset manager is a great tool which will scan all directories that you specify, and it will figure out what content you've got, and you can tell it information about what it is. So if you're not using the asset management, please do so today. If you're building manual lists using data assets as an example of like, here's where all the content is for the weapons in the game, here's the content where all the monsters are in the game, the asset manager will help you a ton here. So with the asset manager, it will iterate through all of your folders, it will figure out where all the content is, and you can use that in your code base to then say, give me a list of all the weapons in the game. And once you've got all the weapons in the game as objects, you can then say, out of all of these weapons, give me the ones that fire projectiles. You can do those sorts of type lookups without having to build your own sort of data tables or your own SQL-like queries within your own game. So custom cooking rules. The other great thing is in one of our games right now, we are doing sort of an open world survival style game. And in that game, we have a lot of points of interest. And those points of interest are levels that are built by level designers, and they are streamed in automatically into the game. And one of the things about Unreal and its cooker is that it's very, very specific. If you reference that content somewhere in your project, it will automatically get picked up by the cooker and it will get cooked in, right? But with maps, it's a little bit different. With maps, you actually have to specify exactly what maps do you want to cook. And because we're creating an open world survival game, we may have hundreds of maps that detail, here's this little spot. If you think of a game like, for example, Valheim, or let's say World of Warcraft, because that might be more popular, you might come across an NPC, or there might be a little farm that a level designer's built. And the way it works is when you encounter it in the game, it'll stream that level in. Okay, so we have this problem. How do we make this easy so that when it comes to figuring out what to cook in the game, we don't have to write this giant list of, here are all the maps in the games that we need to cook? Well, we can create an asset that the asset manager can find, and that will define, here's this level, and here is information about this level. So you might, for that point of interest, it might say, this has a 10% chance of spawning, and it has 50% chance of spawning these items within the chests or something like this. And here is the map that it needs to cook. So when you use Unreal Packager to figure out what to cook, it can go through all of these points of interest style data blocks, and then say, oh, here are all the maps that I also need to include and cook automatically. And you can do this for any number of other ideas that you may have. So how do we use the asset manager in our games? So we have these data assets called definitions. And these things are essentially just data asset objects that store all kinds of information that you may want to look up at any point in time. So as an example, with us, we have items in this open world survival game. And inside each of these definitions for each item, it has its name, it has its icon, it has all kinds of other data relevant to it. Maybe it has like weight. Maybe it has a little description that our great lore designers can add in and things like that. Soft object pointers and class object pointers, so they reference other bits of content. The interesting thing about these definitions is that you can load them up at the game start. So that way you have all of this information already in memory. But you want to be really, really careful not to reference lots of other assets as hard references, because if you do, the game is going to automatically load up all of those assets. And so your load times are just going to incrementally go up But if you have soft object pointers or class object pointers, they're under the hood, they're literally just a string that just says, hey, I'm using this asset here. And then in due time, when you need that asset, you can asynchronously load it. So asset management, we also use it for asynchronous loading and memory management as well. So as I said, we want to avoid having just lots and lots of assets being loaded up at the beginning. And for memory management, we can also say, unload everything that no longer needs to be loaded as well through the asset manager. So highly encourage you to use it. If you're looking to figure out where it is, it is a class that exists within the engine, so you don't need to build it yourself or anything like that. And there probably are examples in Lyra and so forth. But if you're still a bit stuck on where that is, feel free to have a chat to me afterwards if you want to, or you can always email me later on. Okay, so this is about what the asset manager looks like. So in this list here, we've got a bunch of entries. And in here, you can see we've got different types of definitions for all the different types of things that we may want to do in our game. Items, crafting recipes, laws, bits of lore that you can find in the world, So we have this thing where you can walk up to this book on this pedestal, this game is still in the prototype. So, art visuals may not be exactly as I describe it, but you can walk up to it, press a button, and it'll load up what's inside this lore definition, and it will load up all the description text and so forth. So, all right. And this is what a item definition for us looks like. So as you can see, we're storing just lots of different bits of data. So if you pick up this item, it says, here's the item pickup class that you should instance. Here are all the names, here are all the descriptions, icons, gameplay abilities, and things like that you might reference. So it's a great way of collecting all this information. You could try to do this via blueprints, but it's not a method that I recommend, typically because when you load up a blueprint, you actually have to also load up its class, and that itself will lead to longer and longer loading times as you continue developing your project. All right, so instance structs. This is a plugin that that ships with Unreal Engine. And if you're wondering what these are, so these are like instance objects, but they just don't carry all the overhead. So if you're thinking of a case example where we use it in our game, is we have an ability. You cast the ability, and there's a bunch of objects that kind of tell the game, here's the order of execution of things that you must be doing. So for example, you cast the ability, a sound gets played, a particle effect gets made, and an object, in this case a projectile, gets spawned, and out it goes into a fireball, right? And you might be thinking, well, why can't we just do this all in blueprints? And the tricky thing with doing it all in blueprints is that it's a lot of sort of node and code that you constantly have to keep placing down. And if you go down the route of having to go through, okay, I'm going to create lots of subclasses, lots of different blueprints, and I'm just going to copy and paste all of these nodes across, your project gets really unwieldy really, really fast. So in this case, we have a spell definition that can contain these instance structs, and the code execution just says, okay, for each instance struct, just do a thing. So previously in Unreal Engine, you may have used instance objects before, and they provide very similar behavior. The problem is that they're objects, so they're different. So they're treated as objects in the game, and you have to load that up, and it consumes memory and a whole bunch of things like that. With instance structs, it solves a lot of these problems because it's faster performance and it's lighter memory footprint. How is it faster performance? The best way I can explain this is when you go deeper into memory management, with instant objects, over time, you actually get a lot of memory fragmentation. Objects are, if you consider a block of memory, you have some objects here, some objects here, some objects there. And if you're running a class that executes these objects, your CPU is having to jump through different hoops. The analogy I often like to give here is, imagine you're trying to make a peanut butter sandwich, and you go down to your cupboard and you're like, cool, I have the bread, but I'm missing the peanut butter. And you sort of go, okay, well, now I'm going to have to go down to the dairy to pick one up. So you go down to the dairy and you go, oh, it's not there. Then you go, okay, well, I have to go to town to get to the supermarket to go get peanut butter. And so memory hopping is a lot like that. And with instant objects, that's what tends to happen when the memory fragments more and more. But with instance structs, you can shove them all into an array, and the array will be this contiguous block of memory. So as you iterate through the array, your CPU can shove it all into its L1 or L2 or L3 cache, and it can just iterate all through that really, really fast. You may have heard of other concepts like entity component systems and things like that. And a lot of the performance that comes out of entity system components is actually derived from the fact that all these components and all these types of data holders are in these contiguous blocks of memory. Okay, so 5.2, it adds support for blueprints. So you can create, for example, custom structs inside blueprints inside the editor. And then you can convert that into an instance struct, and then you can store that inside your array. So 5.2 adds blueprint support. And it also adds replication support, thanks to a chap named James Baxter. So this allows the system to be fully fleshed, because previously the previous complaints was, if you wanted to replicate structs, or you wanted to use replication with instance stuff, instant objects was the only real way to go, because replication would only occur for objects, but now that's been resolved. So how do we use these instance structs? Well, we use them for extensible gameplay queue notifications. So this is another system where, when a projectile hits a ground or something in the world, it will say, I want to run bits of code, or I want to execute these instance structs. And these instance structs will say, okay, I should be playing a sound, or I should be spawning a particle effect, I should be running some blueprint code, or I should be executing or opening something in the world, or something along those lines. And we can extend it for all kinds of things. There was a stage where we decided we wanted damage numbers, for instance. So when you hit something, or when you cast a projectile at something and it hits an enemy in the world, we wanted damage numbers to come up. So we needed a way to message the systems. And in sort of 10 minutes, I created a little instance struct that just said, okay, I execute this block of code, and I just send numbers through to the damage UI system, and that's how we got it done. So it means that you have a lot less sort of spaghetti code, where lots of different code interlinks with each other. So it's quite nice. Okay, Blueprint supported extensible data containers. So what this means is that you can create TRAs that contain any kind of struct that you want. So instance structs, basically at its core, is just saying that it's just a byte array, and in C++ it'll convert that to whatever array you want to have. So if you've ever had a situation where you said, I have an array, but I want to store a variety of data in this because I don't quite know what I want, then you would convert all of those structs into instance structs and then store them in the array as you please. We also use it for message and data transportation. So for example, when we're creating a drag and drop system, and for example, let's say you want to pick up, you want to grab an item from a chest in front of you and you want to put it into your own inventory. With the UI, you would often have to create a U object in this case to say that's what's inside this chest, and I'm putting it into my own player and his inventory management, for example. And so what we'll do here is actually create an instance struct instead, because again, it's more lightweight rather than having to create U objects all the time. So this is an example of our gameplay queue notification system. So as you can see here, I just create a bunch of these things. And from here, our designer can do whatever they want. And if they ever need a new bit of functionality, I can just add that by adding another type of instance struct I want. And it's this nice, singular sort of, I guess, header file and a bit of code, C++ implementation code, which then does the logic. So we reduce the chances of non-technical people from sort of cobbling together blueprints to do what they want. And then for some of us, we've been in this pain where we see non-technical people just go, oh, that blueprint kind of does what I want. I'll just copy and paste it, or just duplicate it. I'll change a couple of nodes there. Okay, great, now it does what I want. And they'll do this 1,000 times, and suddenly you have tens of thousands of blueprints that are all really, really similar to each other. And really the only real tweaks and changes could be a slight tweak to the formula or slight tweak to the data sets and so forth. So this kind of methodology kind of constrains all of that down. All right, so that's instance structs. So I just want to talk a little bit about extending the Unreal Editor and probably why you should do it. So project-specific tools are really, really good. And it doesn't really matter how big or small your project is. Spending just a little bit of time, like a couple of days, to build a handy tool for your designers or for non-technical people can improve their productivity by quite a lot, an immeasurable amount. So what kinds of things could you add? Like, you can add project-specific information. So as an example, in a lot of our projects that we build, we sometimes we want to add more data to things like static meshes. And so some of the data we might want to add is things like damage areas on the static mesh itself. So in one of our games, Dread Hunger, you had a static mesh which was of an iceberg. And in the game, you can place down a bomb, and when that bomb explodes, it fractures the iceberg, right? And what we wanted in that game is that some areas of the iceberg was more fragile than others. And so the only real way we did that was we said, okay, well, for each vertex on the static mesh, we'll figure out a way to export that data from the editor or from Blender or whatever, and then we'll bake it into the static mesh. But we needed a way to actually visualize that so the designers can also go, oh, okay, I want the fracture points to be here or there. And so for that project, we created a specific tool that actually helps with that, so that they didn't have to go back and forth, because the reason why we did it is because most of the designers didn't want to use Blender. They didn't want to have to leave Unreal Editor to do it. So it was easier for us to just create it. And for Dread Hunger, we weren't a very big team. We were only sort of like 9 core people. So it was a small team, but we wanted to do that. You can also expand existing implementations to improve usability and performance as well. So another example is in our game, open world survival game, or actually our second game was a battle royale game, and it was also open world, and we wanted to have lots of items spawn just everywhere, right? And we didn't want to have to manually place all of these items down. And so what we did was we created a active factory that would spawn the items that you saw on the ground, but we also wanted to randomize it as well. And what we found was when we had this big open world, on the server, it would basically chug, because it was trying to process 1,000 or even tens of thousands different active factories all over the world, spawning all of these items. And we found that was a huge problem. One, there was object overheads with all the active factories that were in the map. And second, a lot of the data that was contained in the active factory was kind of useless. For example, it had things like collision, it had things like the sprites, and it just had all this information that we just didn't care about. If you're wondering why it had collision data, it's so that when the level designers placed it in the level, it would actually sit on the ground or above it, something like that. So what we did there was we created a tool that would scan all of the maps inside this battle royale map and said, here are all the active factories. Now I can compose them into structs and just have a giant list of all these active factories that are in the world. And when the time came to actually look up this data and to spawn things, we didn't have all that actor overhead of iterating through arrays of all these different things. And plus we could extract the exact data that we needed. So that tool was super, super useful. The other types of things that you can build is also things to generate asset icons. So for one of our other games has loads and loads of items in the game. So we planned for this game to have lots of weapons. And we didn't really want designers or artists to spend a lot of time sort of capturing the icon photos and then working through that with Photoshop and then importing that into the game. We wanted that to be automatically done in Unreal Editor. So you push a button, it would scan where all the weapons were using the asset manager, and then it would take an internal screenshot. It would perform whatever it needs to do on the internal screenshot and then save that as an asset in Unreal Editor itself. And that was super, super useful. So if I go to the next slide. So this is an example of the work that we did with extending the editor, where we created active factory previews so that our level designers can click this button. It would update all the active factories so that they could see what was likely to spawn in the world. So as an example, this is our prototype game, and none of these things are actors. They don't actually exist. These are actor factories placed in the editor, but in the game, none of those actor factories actually exist, and this is just a giant giant array full of structs. And the game then processes through that and goes, okay, I need to spawn a pickup here, or I need to spawn some visuals, or I need to do something else. So that was super useful. And this is the asset icon generation. So what you can set up here is basically the editor itself will spawn the asset inside this, sort of behind the scenes. It will take a screenshot. It will then crop the screenshot. You can apply post-processing effects. You can apply different lighting setups and all kinds of things to it. And then you can save the asset and then assign it as a asset icon for the asset itself. So these DAs, for example, are actually the item definitions, or the item data asset in this case. So that way, because the problem is when you create lots of data assets, they all have the same icon. And so after all, your eyes glaze over and you're looking at all these icons, they're all the same except for the names. And so this was a really useful way of tackling two problems. One, it's easier in the editor to actually peruse through this giant folder full of items. And it was also easier for in-game, where the UI in-game can also use these same icons as well. And that way, if the artists made a change to any of the assets, they didn't need to go through that process again. But also, more importantly, if they decided that they wanted different lighting, or they wanted different dimensions for things, or they wanted any other change that they needed on a global scale, they can make these changes in sort of the lighting and staging setup of when the editor actually takes the screenshot. And then they can click one button, it'll iterate through all the items in the game and capture everything and all the icons. So this is the context menu that we also tweak as well. So when you right-click on a data asset, you can also adjust what's actually shown in the context menu. And in this case, I provided the artist an option to say, I want to capture all of the icons again. Or I want to just update this one icon. All right, so we move on to our action graph. So this is leading more into sort of the custom tools that we build for our designers. And in this particular case, where it started was our designer, who's actually here, Carl, he wanted a loot table. So when you killed an enemy, it would drop some items on the ground. And initially, when I was thinking about this problem, I was thinking, well, this can just be an array of a float and whatever item pickup that needs to be. But over time, these rules became a little bit more complicated. It became like, well, I want a 50% chance of dropping this, but I also want then a 50% chance of doing these other 5 things. And then we started thinking about, well, if none of those things happen, we want to fall back into this other loot table. And so the requirements for what a loot would drop from an enemy just became a little bit more complex every time, especially as we started getting more and more excited about, okay, well, what if it did this when you killed an enemy? What if it did that? And so I started thinking about, okay, well, in this case, probably what I want to do is create a really simple graphing toolkit for Carl, in this case, to use so that he can easily just go, when something dies, or in this case, we expanded out to lots of other systems. When something happens and we want a series of actions to execute, we can allow these action graphs to be used. So the next step is thinking, well, why don't I just use blueprints for this? And the answer to that is, one is that blueprints can be quite heavy for this particular task, because you can create a blueprint which has a static function, for example, and then that static function can do a bunch of things, and that's similar. Or the other way of doing it that you might be thinking is, well, you just spawn the blueprint, and then the blueprint will do its thing, and then you destroy it. Well, the big problems with that is that, one, it's going to lead to a lot of memory fragmentation over time, and second, it's really heavy to spawn things into the world. So spawning actors or instancing objects in the world is just a heavy process. You want to avoid that as much as you possibly can. So I wanted a system that was really, really lightweight compared to blueprints, but I also wanted to constrain the system so that you didn't accidentally go, oh, I'm just going to use this timer here, or I'm just going to use this asynchronous task here. And I wanted to avoid those kind of traps because yes, it'll work, but when it comes time to shipping the game, where you're trying to figure out where all the performance hitches are coming from, or where other problems are coming from, or referencing problems come from, typically they come from blueprints. And so by removing blueprints from the equation and adding a different system altogether, it just solves a lot of those issues. One of the funnest things that we had to do with our second game was we kind of just told the level designers, you can make blueprints if you want, and they can just do whatever. And we wound up with 5 blueprints that caused 90% of our performance issues, because all of them had a function that ran on every single frame that said, for all the actors in the world, I want to do this thing. And it tanked performance so hard, and it took us ages to figure it out. So, and by the time we got around to it and go, oh, well, that's the problem, let's delete this, like 100 maps were all referencing this blueprint. So it was really hard to get rid of at the end of the day. But we got there. I also had a really strong desire to make this data only. And the reason why I wanted to be data only is, again, I really wanted to be able to use the asset manager for this to preload them into memory. And then that way, when it came time to execute these actions, or these action graphs per se, I could just point to it and it'll just run and it'll be fine. I don't have to instance anything. I don't have to spawn actors or anything like that to make it work. But the big thing that I wanted to point out in this is that a lot of the graphing toolkit is exposed in Unreal Editor, and also in C++. And I highly recommend you should actually look at this for almost anything that you can think of that would make for a really great sort of tool for an artist or for a designer to use. So another example that I have is, in this game we have quests, and we wanted to have, sort of to lay out quest structures and things like that. And I haven't done it, but the plan was eventually, rather than having all these separate objects for quests where you go like quest here, quest here, quest there, and then you manually go like this quest references this quest and this quest reference, like eventually that gets really confusing. And so what I wanted to do was to use a graphing toolkit so that you could say this quest will unlock these 2 other quests, and this quest will unlock these other quests, and so forth. And what that also allows you to do, because it's data only, is you can bake all that information out. You can then sort of pre-generate a whole bunch of data based on that. So if for another great example I can think of, if you have a game where you have something like a research tree, you could use the graphing toolkit to build a tool for the designers so that they can just place all the research bits. And now that you have it all as a tree of data and it's data only, you could build your UIs off that. Fantastic. So all of that work doesn't need to be duplicated. So this is an example of what the action graph toolkit looked like in the end. And this took me about 2 days to build. And now I suddenly didn't have to do any of this work. I could just hand it all over and be like, here you go. Here's this action graph system that you can now use. And adding each one of these nodes is really, really straightforward. And it made my life a lot easier. So I highly recommend it. The reason why it took me 2 days is because 1 day was for learning how the graphing toolkit in Unreal worked. But you have lots of examples. You have the blueprint editor, you have the animation graph editor, you have the meta sound editor. Like there's all these examples that exist. And you could do much more complicated things than this. Like you could show models inside here or textures inside here. You could do all kinds of things. But for a very simple use case and for a very simple tool like this, a couple of days is pretty much all you kind of really need. Go from there. All right. All right, so I'll delve a little bit further into the asset icon generation. So in one of our projects, as I mentioned, we wanted to have hundreds of items. And we didn't want to generate these by hand. Okay, we've been through that. So I wanted to talk about the additional customization using blueprints, and also additional customization by exposing various properties. So the way that it works under the hood is that Unreal Editor, when you ask it to generate an icon for one of the items in our game, it will actually instance a new world. And when it instances this new world, it will then spawn a blueprint inside this new world. Now that blueprint can contain a whole bunch of things that you might want. So it can, for example, add a post-processing volume, which influences the camera which captures the icon. It can instance a whole bunch of lighting. It can instance other meshes behind the icon that you want. So if you don't want a clean icon, for example, but you wanted to do, for example, you wanted to add like a background image, or you wanted to add, or you wanted to add anything else that your designers may want to do, they add it into this blueprint. And you can also expose a lot of other properties. So for example, if you wanted to overlay another texture on top of the icon, if you wanted to modify the icon in any other way, say through a color lookup table or any other image manipulation, you could do it through this. So here is an example of the blueprint setup that we have. And as you can see, it just has a whole bunch of area lights in here just to light up the thing that we want at the end of the day to take the icon off. And this is sort of the data asset that we use, which is also used by the asset manager. So when it comes time to generate all the icons in underlying code, we ask the asset manager, hey, what are all the items that are in the game? And what do they link to in terms of the capture properties? Look all of that up, and then we capture all of our icons. So Unreal Editor ships with a ton of great tools. But that should not stop you from creating your own custom tools so that you can improve the productivity of everybody else. And this is just an image of, again, the further details. So previous image was a data asset of the global capture settings that we wanted, and then this is more specific, as in this item should use these specific rules, this FOV, or this lighting conditions, and so on. Okay, automated testing. Automated testing has been an interesting talking point within our studio for a while now. We've always wanted to do it, but we've always kind of struggled to do it. And one, I think, thing to think about for our studio is that we're not particularly large. We're only about 16 of us. And so we needed ways to validate our game and to test functionality within our game to actually remove a lot of the burden from the QA and testing team. Automated testing, as Jack mentioned in his previous talk a little bit, is that you definitely want to allow designers to do all kinds of things, but you want ways to allow them to validate that what they're doing is actually good or correct. In our previous example, where we had the designers creating 5 blueprints, which caused 90% of our performance problems, it would have been great to have an automated test then to say, hey, please don't submit this because this is going to cause a ton of performance problems. The next thing is that data validation is really, really, really incredibly important, particularly as we shift more and more of this work to designers. They're not going to necessarily have the technical background to understand, okay, this is bad, this is good. In that sense. So what you can also do from here is that automated testing combined with automation servers will also make that really useful. So for example, we have automated tests which are constructed in Unreal commandlets. So in Unreal Engine, you can create little commandlets using C++. The reason why you want to create these commandlets is because they have access to all of Unreal Editor's toolsets. So you can look up packages, you can use the asset manager, you can look up what's inside that asset. So for example, if you want to do validation on textures, you could write that as a commandlet. And the commandlet can look up what all the textures are that are being used in the game. It can look through all of their properties, and you might say, all these textures are in the wrong texture group. And maybe you want to provide a warning about that. Or you might want to do other things, such as saying, these item definitions have been set up incorrectly because they're missing icons, or they're missing descriptions, or they're missing whatevers. And you can hook that in with something like Jenkins, as an example, to do this on a weekly process or a nightly process. You could also even do it as a submit hook. So if somebody was to submit an item definition that was, say, missing descriptions, or missing some other important piece of information, as they submit, they can either get a warning straight away, or on cook the next day, it can then say, hey, people submitted this and this was what was wrong. So internally, I think this is more of a aspirational goal, is that we try to run them often and report problems to catch them early. Having no surprises is always really, really nice. So this was not a particularly good, fun day. We had a lot of errors in our content. But you can see sort of the sort of really nice uses here. We can also use automated testing to test various chunks of code as well. So in our case, we have, in our open world survival game, we have an item management component, and in it has a bunch of functions to add an item, to remove an item, to duplicate an item, and all these different things. And you can write very simple automated tests to basically run those functions for you. And you compare it with the inputs, and you compare the outputs, and you go, cool, this function still works. And that way, if anybody works on the code base towards the future, they can always run these automated tests and know have they broken that functionality or not. And super, super useful to do that. This was also not a particularly fun day. So this is the asset validation within Unreal Editor itself. And this again is a super useful tool that I highly recommend everybody should be using. And you can automate this as well. So it just removes a lot of those headaches where you sort of go like, when you get to shipping the game and the package then goes, you have all these errors and you have to fix them. And so what turns out to be, yay, we can ship tomorrow, it turns out to be mad emails to everybody saying, hey, we can't ship tomorrow, can we push it to next week, and so on. So you want to avoid that as much as you can. Cool, looks like I finished a little early today. But thank you so much. I know I rushed through a lot of that, and there's probably a lot there that you might have questions for, so please ask them. I'm happy to elaborate and expand on any of the topics here today. So thank you so much for listening. Yeah, we'll do a Q&A. I went through it a little bit faster than I thought.
If you guys have any questions, I can bring the mic round to you, and we can ask any questions if you have any.
I'm also open to talking about other experiences with our studio and things like that as well. So I think one of the biggest things that we went through when it comes to sort of all of these things with automated testing was that it was a really hard process for us to get sort of underway as well, because most of the time I'm an engineer myself, so I spend a lot of time just writing code, and I don't test it a lot, and I sort of just ship it out there and hopefully it's bug free, but that's often not the case. And so automated testing was a difficult thing to do, but one thing I will say is that Unreal Engine with its Unreal commandlets, being able to integrate that into the editor has made things a lot nicer for us, especially when we can combine it with instance structs and all those different types of things. The other bits with asset icon generation, as an example, is you can do so much more. That's just sort of scratching the surface of what you can do. So if you need to generate other metadata for your assets, and this can be for a variety of reasons, maybe it links to JSON externally outside Unreal Editor, for example, or maybe it links to other asset resources or something. You can set up tool sets to actually just work through all of those things to make it so much easier and increase productivity at the end of the day. So yes. Thank you.
Thank you very much. So we are already using MapCheck and some other testing things within our engine, and we found it really helpful to expose some of that stuff to blueprints to make it faster to like rapidly make a test. It's a lot nicer to make a test if it's really quick and easy to just smash something out very quickly while you're testing something. Do you have any, I guess, advice or ideas when exposing some of that stuff to blueprints? Because there was a bit of a minefield there as well.
Just so I understand the question correctly, you're asking if you can expose some of the stuff to blueprints to
exposing some of the testing, like, because it's all really in C++, exposing some of that to blueprint. Have you tried that? Are there any issues with that you've come across? Because we've tried a little bit of that ourselves.
Yeah. I have tried some of those things before. So the really nice thing about blueprints is that they don't have to just execute in the game. They can execute in the editor just fine as well. And so sometimes what I have done in the past, for example, is to create blueprintable classes, which you can then say for these types of assets or for these classes, execute this function to validate them. And so if you expose that, I think editor blueprint utilities is where you can go with this as well. And then that way, when designers say, I'm going to be adding this new thing, or an artist says, I'm going to be wanting to check for this thing, almost non-technical people can also jump in and be like, okay, I'm going to add this test as well. So yes, you definitely can do that. And blueprints is definitely not just restricted to just, executing within the game itself. So blueprint utilities and blueprint code management style things can definitely happen as well, which is great. So yeah, definitely recommend it.
There are no other questions. I
Cool.
think I
All
will thank you for your talk.
Cool. Thank you.
Nami here, James.
Yep. Thank you.